Chapter 7 is about data collections, arrays, matrices, and vectors, and our first program in Chapter 7 is going to be Alphabet. Let's talk a little bit about arrays before we get started. So an array allows you to store and work with multiple values of the same data type. The values are stored together in consecutive memory locations. An array's size declarator must be a constant integer expression with values greater than 0. It can either be literal, as in the top example, or a named constant, as in the bottom example. Arrays are a one-dimensional storage structure. Each piece of data in an array is called an element. To access the individual elements, you use subscript operators inside of the square brackets and index positions that start at 0. It is standard coding practice to name the index position variable as 0. Arrays are fixed in length. Once they're declared, you can't make them any longer or any shorter. Even though an entire array only has one name, the elements may be accessed and used as individual variables. This is possible because each element is assigned a number known as a subscript. A subscript is used as an index to pinpoint a specific element inside of an array. The first element is assigned to the subscript 0, the second element is assigned to 1, and so forth. Please note that the expression hours and then a square bracket with a 0 inside is pronounced hours sub 0. So you would read the assignment statement hours array starting with 0 equals 20 as hours sub 0 is assigned 20. You do need to make sure that you understand the difference between the array size declarator and a subscript. The number inside the brackets of an array definition is the size declarator. The number inside the brackets of an assignment statement, or any statement that works with the contents of an array, is a subscript. Even though the size declarator of an array definition has to be a constant or literal, subscript numbers can be stored in variables. This makes it possible to use a loop to step through an entire array, performing the same operation on each element. For example, look in the code at the top right. This code first defines a constant int named array size and initializes it with the value 5. Then it defines an array named numbers using array size as the size declarator. As a result, the numbers array will have 5 elements. The for loop uses a counter variable named count. This loop will iterate 5 times, and during the loop iterations, the count variable will take on the values 0 through 4. Notice in the program on the screen how they see out the employee number array elements on each line. So pay attention to the for loop that they've created and how they're outing each of those elements. Like regular variables, C++ allows you to initialize an array's elements when you create the array. Here's an example. The series of values inside the braces and separated with commas is called an initialization list. These values are stored in the array elements in the order they appear in the list. Figure 7.9 shows the contents of the array after initialization. If we create an int array with the name num written out like this, it is stored in 2 separate locations. The variable itself is stored in one place, but the array values are stored in a different place. This means that the memory location for the int num is actually holding another address instead of a variable. Back in Programming 1, we learned about strings. In Chapter 10, we're being introduced to a similar concept called a C-string. A C-string is a sequence of characters stored in consecutive memory locations and ended or terminated by a null character, which is also known as a null terminator. You have to think back a ways, but we talked in Chapter 2 about how a null character or null terminator is a byte that holds the ASCII code 0. Strings that are stored this way are called C strings because this is the way strings are handled in the C programming language. This program contains 2 string literals. C++ programming is great fun. And do you want to see the message again? The first string occupies 30 bytes of memory, including the null terminator, and the second string occupies 39 bytes. Just to emphasize, C++ adds a null terminator, or \0, at the end of a string that's stored in a character array. So you always need to make a character array in C++ one element longer than what you're storing. So in this program on the screen, notice how to see out a character array. They've set the declarator for num letters to 10, but counting starts at 0, which means we actually have 11 spots of memory reserved. This is for the 10 numbers and the null terminator. In Chapter 7, the author mentions that you can create an array with a name, but no brackets and no subscript. Of course, CN has no way of knowing that line has 80 elements. If the user enters a string of 81 characters, CN will write past the end of the array. This can be prevented by using CN's getLine or get member functions. So cn.get or cn.getLine will read in an entire string, even if it included delimiters such as spaces or tabs. The first argument in the code on the screen tells getLine where to store the string input. This statement indicates the starting address of the line array as the storage location for the string. The second argument indicates the maximum length of the string, including the null terminator. In this example, the size constant is equal to 80, so CN will read 79 characters or until the user presses the enter key, whichever comes first. CN will automatically add the null terminator to the end of the string. Once a string is stored in an array, it can be processed using standard subscript notation. For example, in program 10.5 on the screen, it displays a string stored in an array. It uses a loop to display each character in the array until the null terminator is encountered. Also in Chapter 7, it mentions that one array cannot be assigned to another array with the assignment operator, or the equal sign. Each individual element must be assigned, usually inside of a loop. The strcpy, the string copy function, can be used to copy one string to another. Here's an example of its use. The string copy function's two arguments are C string addresses. The contents of the second argument are copied to the memory location specified by the first argument, including the null terminator. If anything is already stored in the location referenced by the first argument, it gets overwritten, as shown in the following program segment. To use string copy, you need to add the program header file #include string.h, which some of you have already used in place of the normal string header file. Because string copy performs no bounds checking, the array specified by the first argument can be overflowed if it isn't large enough to hold the string specified by the second argument. Because of that, it's better coding practice to use this strncpy function. The string in copy function allows you to copy a specified number of characters from a string to a destination. So calling the string in copy is similar to calling strcpy, except you pass a third argument specifying the maximum number of characters from the second string to copy to the first. See the example that just came up on the screen. When the statement executes, strncpy will copy no more than 5 characters from string 2 to string 1. However, if the specified number of characters is less than or equal to the length of string 2, a null terminator is not added to string 1. If the specified number of characters is greater than the length of string 2, then string 1 is padded with a bunch of null terminators up to the specified number of characters. The following code shows an example of using the string in copy function. So for alphabet, you're going to declare a character array named alphabet, and you're going to initialize it to A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. In an appropriate loop, you're going to replace one character of the array at a time to lowercase letters. So there's two possible ways to do this. You can either change the integer ASCII code for the character, look at the back of your book, or go to the website that's on the screen, or you can use a library function. You're going to print the entire character array to the screen each iteration of the loop. Do not worry about making the output meaningful or see outing blank lines in between. We are just worried about using an array correctly. So the output should look all like this. The first line will be all caps. The second line, A is lowercase. The rest of them are all caps. The third line, A and B are lowercase, and then the rest are all caps, etc., etc., all the way down until all of the alphabet is in lowercase letters.